To find the slope of any line, you'll first want to know the slope formula. Which of these is the correct formula for the slope between the points x1, y1 and x2, y2? Exactly, the general formula for slope is y2 minus y1 over x2 minus x1. So to find the slope of a line, you can pick any 2 points, call them x1, y1 and x2, y2, and then plug their coordinates into this formula up here. So try using these 2 points to calculate the slope of this line. Nicely done. So again, the slope is y2 minus y1 over x2 minus x1. Plugging in the y coordinates for these points, y2 is 3 and y1 is negative 1. And plugging in the x coordinates, x2 is 3 and x1 is negative 5. So the slope is 3 minus negative 1 over 3 minus negative 5. 3 minus negative 1 is 4, and 3 minus negative 5 is 8. So the slope is 4/8, which equals 1/2 or 0.5. So what happens if we try calculating the slope using a different pair of points? So let's call this point x1, y1 and this point x2, y2. So now calculate the slope of the line. Hopefully you'll get the same answer. Right, we can again calculate the slope using this formula. y2 is 4, y1 is 2, x2 is 5, and x1 is 1. So the slope is 4 minus 2 over 5 minus 1, which equals 2/4, or once again 0.5. So to find the slope of a line, you can pick any 2 points on the line and you'll always get the correct answer. Now what happens if we switch these 2 points? So instead of calling this point x1, y1 and this point x2, y2, we call this point x1, y1 and this point x2, y2. So now that we've switched which point we're calling the first one and the second one, try calculating the slope again and see if you still get the same result. Nicely done. Earlier you calculated the slope as 4 minus 2 over 5 minus 1. But now that we switched which is point 1 and which is point 2, we actually have 2 minus 4 over 1 minus 5. So now, instead of getting 2/4, we have negative 2 over negative 4. But the minus signs cancel, so this still equals 1/2, or 0.5. So we could call this point 1 and this point 2, or we can call this point 1 and this point 2. It doesn't matter. Either way, we get the same slope. This means that up here we have one formula for slope, y2 minus y1 over x2 minus x1, but if you switch what you call point 1 and point 2, you get another formula for slope, y1 minus y2 over x1 minus x2. This formula gives you the same slope as this one. So let's try another example. For this line here, let's call this point 1 and this point 2. Try calculating the slope of this line using this formula, y2 minus y1 over x2 minus x1, and with this formula, y1 minus y2 over x1 minus x2. You should get the same answer for both formulas. Excellent! So with this formula you got 3/2 or 1.5, and with this formula you get negative 3 over negative 2. The minus signs cancel, and again you get the same answer of 1.5. So to summarize, here's how you can find the slope of any line. First, pick any 2 points on the line and call their coordinates x1, y1 and x2, y2. Then you can find the slope using either one of these formulas, y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Both of these formulas will give you the correct slope. Before we get to slope, can you identify which 2 of these lines are parallel? If you're not sure, click down here to review. Right, these 2 lines are parallel. They both run in the same direction and they never intersect. Next, let's draw in a coordinate plane. it looks like this line passes through the points -5, 2 and -2, 4. And down here, this line passes through -4, -3 and 5, 3. So now let's find the slopes of these lines. First, calculate the slope of this line up here, or click down here to review. Exactly, the horizontal distance is +3 and the vertical distance is +2, so this slope is 2/3. Next, let's look at the line down here. Try calculating the slope of this line. Right, the horizontal distance is +9 and the vertical distance is +6, so this slope is 6/9. And we can simplify this fraction. 6/9 is the same thing as 2/3. So sure enough, these two lines have the same slope. In general, parallel lines always have the same slope. This makes sense because the slope of a line tells you its direction, and parallel lines run in the same direction, so parallel lines have the same slope. So if I were to tell you that these two lines are parallel and this line has a slope of -1.3, then what's the slope of this line? Right, because these two lines are parallel, that means they have the same slope. So this slope also equals -1.3. For your final challenge, suppose I tell you that two lines have the same slope. Then which of the following are possible? Could it be that the lines don't intersect anywhere? Could it be that they intersect exactly once? Or could it be that they're actually the same line? In other words, for which of these cases do the two lines have the same slope? Check all that apply. Exactly right. So if someone tells you that two lines have the same slope, then those two lines could be parallel, but they could also be the same line. Lines that intersect like this are not parallel, and they have different slopes. One line is definitely steeper than the other. So to summarize, parallel lines, like these two lines here, always have the same slope. Before we get to slope, can you identify which two of these lines are perpendicular? If you're not sure, click down here to review. Precisely, these two lines are perpendicular. They form right or 90-degree angles at their intersection. Next, let's draw in a coordinate plane. It looks like this line passes through the points 1, 1 and 6, 4. And this line passes through -2, 3 and 1, -2. So now let's find the slopes of these lines. First, calculate the slope of this line, or click down here to review. Exactly, the horizontal distance is +5 and the vertical distance is +3, so this slope is 3/5. Next, let's look at this line. To go from -2, 3 to 1, -2, you can move right and then down. So it looks like this line has a negative slope. So try calculating the slope of this line, or click down here to review negative slopes. Exactly, the horizontal distance is +3 and the vertical distance is -5, so this slope is -5/3. So let's take a look at the slopes of these two perpendicular lines. It looks like they're related. This slope is negative and this slope is positive, and they're both fractions, but the numerators and denominators are flipped. Let's see if we can prove that perpendicular slopes are related like this. Suppose you have 2 points on a line. Let's represent the horizontal distance between them as the variable a. So this distance is some number, but for now we don't know what it is, so we'll call it a. And let's call the vertical distance another variable, b. So then what's the slope of this line in terms of a and b? Right, the slope of this line is the vertical distance, b, divided by the horizontal distance, a. Now, let's rotate this line by exactly 90 degrees. And we can rotate it another 90 degrees, and then one more time. Together, all these lines look like a pinwheel. But if we focus on the blue lines, then sure enough, we can see that they're perpendicular, because we were rotating by exactly 90 degrees. Now this horizontal distance is the same as this vertical distance, so it's a. And this vertical distance is the same as this horizontal distance, so it's b. So looking at this line over here, which goes to the right a distance b and then down a distance a, can you figure out its slope in terms of a and b? Nicely done. The horizontal distance is positive b and the vertical distance is negative a. So the slope of this line is negative a over b. So it doesn't matter what number a equals or what b equals. Perpendicular lines always have slopes where one is negative, the other is positive, and the numerators and denominators are flipped. A fancier way to say this is that the slopes of perpendicular lines are negative reciprocals of each other. In other words, if you know one of the slopes, you can find the other by finding its reciprocal, meaning flip the fraction over, and then multiplying by negative 1. Let's make sure that works. Starting with the slope of this line, b over a, let's flip the fraction and then multiply by negative 1. So now we have negative a over b. So by flipping the fraction and multiplying by negative 1, we got the slope of this line. And if we started with this slope, negative a over b, we can flip the fraction and then multiply by negative 1. Then the minus signs cancel, so we have b over a, which is indeed the slope of this line over here. So the slopes of perpendicular lines are always negative reciprocals of each other. Now suppose I tell you that a line has a slope of 2/3. What's the slope of a line that's perpendicular to it? Try using these steps to figure it out. Excellent work! The negative reciprocal of 2/3 is negative 3/2. You flipped the fraction and put a minus sign in front. So the slope of the perpendicular line is negative 3/2 or negative 1.5. We can draw some lines to double check. Here's a line with a slope of 2/3, and here's a line with a slope of negative 1.5. Sure enough, they're perpendicular. Next, try another example. If one line has a slope of negative 1/4, what's the slope of another line that's perpendicular to it? Exactly. The negative reciprocal of negative 1/4 is positive 4 over 1, or just 4. To check, here's a line with a slope of negative 1/4, and here's a line with a slope of 4. They are indeed perpendicular. Okay, so what if a line has a slope of 7? What's the slope of the perpendicular line? And remember, you can also write 7 as the fraction 7 over 1. So give this question a shot. Right, the negative reciprocal of 7 is negative 1/7. Here's a line with a slope of 7, and here's a line with a slope of negative 1/7. Again, they're perpendicular. So if a line has a slope of exactly 1, then what's the slope of a perpendicular line? Precisely, 1 is the same thing as 1 over 1. So the negative reciprocal is then negative 1 over 1, or negative 1. So lines with slopes of 1 and negative 1 are perpendicular. To check, here's a line with a slope of 1, and here's a line with a slope of negative 1. Once again, they form right angles at their intersection. Now what if a line has a slope of 0? Well, 0 is the same thing as 0 over 1. So the negative reciprocal would have to be negative 1 over 0. But remember, you can't divide by 0. So this expression is undefined. So the number 0 does not have a reciprocal. But it turns out that lines with a slope of 0 and a slope that's undefined are still perpendicular. Here's a line with slope 0. It's a horizontal line. And vertical lines have an undefined slope. So sure enough, these two lines are perpendicular. For your final challenge, try identifying which of these pairs of slopes belong to perpendicular lines. So in other words, are lines with slopes of 4/6 and negative 3/2 perpendicular? What about lines with slopes of 5/7 and 7/5? And for these decimals over here, you might want to first write them as fractions. This is a tricky question, but there are some perpendicular slopes here. Excellent work! You can simplify 4/6. It's the same thing as 2/3. 2/3 and -3/2 are negative reciprocals of each other, so these two slopes are perpendicular. 5/7 and 7/5 are reciprocals, but they are not negative reciprocals, so lines with these slopes are not perpendicular. Over here, 0.5 is the same thing as 1/2, and -1.5 is the same as -3/2. These numbers are not negative reciprocals, so they're not perpendicular. And down here, -0.4 is the same as -2/5, and 2.5 is the same as 5/2. So these two numbers are negative reciprocals, meaning lines with slopes of -0.4 and 2.5 are perpendicular. Again, this was a tricky question, so nicely done.